right, so we're going to finish 2.3 today, and we started 2.3 last time, and one of the things that we kind of left off on is we left off on some pictures, and the pictures look like these. We talked about how to shade a Venn diagram when we are given information about the different sets that are in the diagram. And one of the ways we talked about doing that is to create either 2 circles, if there's 2 sets, or 3 if there's 3, and label them, of course. And then we have to get the regions, the different little pieces of area, a name. And what we did is we used numbers to name them. Everybody with me? Remember? Okay. So we're going to pick up on that idea with an additional problem. And the problem that we're going to take a look at is this set, where we're going to take A intersect B complement intersect C complement. Okay? So what are we going to do first? Draw a box, a rectangle, right? And what's going to be inside our rectangle? 3 circles, because there's 3 letters. All right, what are we going to do with these 3 circles? Before we number them, let's label their names, all right? So I've got circle A, circle B, circle C, and I also need to label U on the outside the box. Okay, then that's right, I do. I want to put numbers in these different areas so that we can talk about them from a concrete perspective. So the way that we did our numbers last time, just to keep them all in order, is we started with 1 here, went across to 2 and 3, we went across the middle, 4, 5, and 6. 7 was down here in circle C, and then we had 8 on the outside. All good? Who wants to volunteer? I'm going to pick on somebody who's going to be volunteers. That would pick on you. Come on up. You knew it was going to happen, didn't you? You're about to volunteer. Now you get volunteer. You don't need anything. Just come on up. You're good. You're going to come up to the board and you're going to write today. All right. What is she going to write down first? You get the help of the class. You don't have to write it on your own. What does she need to do first? Figure out what's in A. Because A is in the parentheses, right? All right. So somebody tell her what numbers she needs to write down for A. 1, 2, 4. Perfect. Now what does she need to do? B complement. All right, so what does B complement mean? Everything that's not in B. So what numbers would that include on this diagram? 1, 4, 7, 8. Perfect. 1, 4, 7, and 8. Oops, no 3.
I'm kidding.
You're good. You get to practice the eraser. That's a good thing to practice. 1, 4. What else does she need? 7, 7, 8. Okay, what's the next step? So draw a line, right? And then what does she need to do with those? She needs to intersect them. So write down everything inside the parentheses, right? And that symbol inside, as you guys have said, is intersection. What does intersection mean? If it's in both, what they have in common, right? So what numbers will that include? 1 and 4. Very good. What's next? What's outside the parentheses, right? Because we did everything inside. Okay, good. So we've got C complement next, yeah? Okay, what's in C complement? What numbers does she need to write down?
1, 2, 3, 8.
Excellent. The numbers outside of C. So 1, 2, 3, and 8. Can we draw another line? Sure. And then what? Write everything. So let's write it all joined together as in the exact problem we were given. Okay, so what is the symbol between the 2 sets this time? Oh, I'm hearing both. Which one is it? Intersection, because it's the upside down U. Intersection. What does intersection mean? In both. What 1 or 1 numbers or what goes in both? The number 1. Anything else? No. If she stops here, is she finished? She needs to shade. What does she need to shade? 1. Can you shade for us? That's all? This was relatively painless, wasn't it? Okay, so remember this from last time? Yes. Okay, so you're going to do some examples like these in your homework. All right, one other thing we're going to do is the diagrams then. Okay, so if you take a look at this particular diagram or problem, we're going to draw a Venn diagram, but we're not going to be shading. The directions say draw an appropriate Venn diagram and use the information to fill in the number of elements in each region. So let me tell you what that information is. So we're going to start with the number of items in A is 24. The number of items in B, also 24. The number of items in C is 26. The number of items in A intersect B is 10. The number of items in B intersect C is 8. And the number of items in A intersect C is 15. 2 more pieces. Number of items in A intersect B intersect C is 6. The number of items in the universal set is 15. Diagram out the same way we did before. I have 3 different descriptions, A, B, and C. I need 3 circles. All that's the same. The difference between this and the last problems is the fact that the numbers here aren't just representing places on my picture. They're actually representing the number of items in those locations. Okay? So we'll start with our picture. And in my picture I need what? 3 circles. Whoa. Make it so big, huh? Let's try to move that. And I'm going to label my circles. And you. Alright. Now, here's the deal. If I start with the first piece of information, that is the fact that the number of items in A is 24. Then it means the entire circle A, all of those pieces, and there are 4 different pieces of that circle, right? There's this outer piece, there's this piece where it overlaps a little bit with circle B, there's this piece where it's overlapping a little bit over here with circle C, and then there's a place where it overlaps with all 3 circles. All 4 of those locations have to, combined, be 24. And I don't know about you, but I don't want to trial and error my way around with 24 and figure out which pieces go where. There's 4 different things I have to play with. It doesn't seem like a very efficient way of doing the problem. Make sense? So starting with any of these pieces on this top row is not a helpful place to start. Okay, so let's use the second row. I'm doing better on the second row. This says A intersect B is 10. But the circles A and B right here intersect again in 2 locations in the middle here, right? This top piece and this bottom piece. And while there's less trial and error, I still don't want to do trial and error if I can avoid it. Right? Okay, so anything on this middle row where they're talking about the 2 circles overlapping, they overlap in 2 places, I have to use trial and error. The second or the third row, these 2 pieces of information, this piece right here is a very helpful thing to say. Because what is A intersect B intersect C? It's that very center piece, which there's exactly 1 of, right? Like that. We can put something in there. I don't have to do any trial and error. So what's going to go in the middle? 6. That's awesome. And the cool thing is that once I've done this 6, I'll mark a line through it so that we know what pieces we've done. Once I've done this 6, then all 3 of the pieces on row 2 there can be done. Because they were all overlapping with that very center piece. So let's look at one of them. Let's just use the first one here. A intersect B right there. So A intersect B is this piece right here, right? So those 2 pieces combined have to be 10. which means how many am I missing currently? 4. So I can put 4 of them right here. And I've done this piece. Let's do the next one. B intersects C. Well, B and C intersect right here. It includes the 6 in the middle, but the total has to be 8, which means how many am I missing? 2. So I'll put a 2 out here. And I've done that one. Last one, A intersects C. So A intersects C over here on this piece. And A intersects C includes the 6 in the middle, but it's supposed to be a total of 15, which means I'm missing 9. So I'm going to put a 9 out here, and I'm done with this piece. All right, so now I'm actually able to go back up to line 1 of this work, and I've got all the information I need to be able to use it now. So again, we'll start at the beginning, circle A. Circle A is supposed to have a total of 24 in it, correct? And right now, circle A has a 9 and a 6 and a 4. What's 9 plus 6 plus 4? 19, which means how many am I missing? 5. So I need 5 to go out here in the outside of this circle. All right, let's do circle B. So circle B over here, it's supposed to add up to 24. Right now it has a 4 and a 6 and a 2 in it, which is a total of 12, which means how many are missing? 12 to get that add up to 24. Good? We're almost done. Circle C is supposed to add up to 26, so this is my bottom circle here. I've got 9 and 6 and 2, which is a total of what? 17. And if it's supposed to add up to 26, how many am I missing? 9. 9, right? So, I've got that piece there taken care of. All good? Am I finished? No, what's wrong? Yeah, so the picture should have a number outside in that outer rectangle, and right now it doesn't. And I've got one piece of information I haven't used, so I should be able to use it to find that number on the outside. Everyone agree? Excellent. So the number that's supposed to be on the outside has to do with this 50, but it's not 50 on the outside. That's not what that says. What does n of u being 50 actually tell you? Everything in the whole picture must be 50. So can somebody grab a calculator and add up everything in the picture? Did you already add them up for me? Thank you, Beth. 47. That tells me that everything in all my circles are supposed to be 47, which means how many are missing? 3. So I've got 3 on the outside. Okay, does it make sense? We're kind of working inside out, kind of like you worked with parentheses. All right, let's do an application of this idea. All right, we've got Joe Long, and Joe Long works on albums for musicians. Last year, he worked on 12 projects. He wrote and produced 2 projects. He wrote 5. He produced 7. All right, so we're going to draw a Venn diagram for this idea. How many different circles am I going to need in this diagram? 3. Do I? 2. Why only 2? Right. We've got a piece, we've got information about a circle being that ones he wrote, and then we've got an information about ones he produced. So my 2 circles, whoops, not do that, hang on, are going to be labeled, one of them, these albums he wrote, and this other one, the ones that he produced. And then we'll call this the universal set on the outside. It tells us some information. It says he wrote and produced 2, he wrote 5, he produced 7. Where do I start with that information? In the middle. And do we know what number goes in the middle? 2. Because this is where they overlap. This piece in the middle is the and. It's the wrote and produced description. So there's 2 of them. Now it says he wrote 5. So am I supposed to put a 5 out here in the row circle? No, I need 3 because everything in the row circle should add up to 5, right? All right, great. Now it says how many did he, or it says he produced a total of 7. What's that going to tell me to do? Subtract, so I've got 7 minus 2 is going to be 5, right? And the 5 goes in this piece over here. Am I done? What's wrong? There's a universal set here, U, and I need something that's outside of this rectangle. Sometimes it could be a 0. This time, I don't think it is, right? What number is going to go on the outside? A 2. Why? He worked on 12 projects, which means all these numbers are supposed to add up to 12. And right now they only added up to 10, so I need 2 more. Okay, once I have my picture, I can go back and answer the questions that I'm asked about this. This one says, how many projects did he write but not produce? 3. How many did he produce but not write? Good. And how many did he neither write nor produce? 2. And if you mess up on your diagram, I promise I will grade your questions according to your diagram. Okay? So you don't get double weighted. Okay? Your answers need to match the diagram that you produce. Make sense? All right. Now just a couple more. All right, a youth group was asked questions regarding songs that they learned as children. Upon surveying the 34 youth, the following results were obtained. 15 learned Jesus Loved Me. 18 had learned This Little Light of Mine. 28 had learned the B-I-B-L-E. 13 had learned both of these, Jesus Loves Me and the B-I-B-L-E. 15 had learned This Little Light of Mine and the B-I-B-L-E. And then 14 had learned This Little Light of Mine and Jesus Loves Me. Does anybody work with kids in their church? Do we sing these songs? Yes. Good. All right. And then it says 13 had learned all 3. And then we've got some questions about this. So what are we going to do? A Venn diagram. How many circles are going to be in my Venn diagram? 3. What are these circles going to be? All right, so one of them is going to be Jesus Loves Me.
This little light of mine.
Okay. So one of my circles is going to be, what do we want to do first? Jesus Loves Me? What's the second one?
This little light.
Okay. And then the third one? Excellent. All right, I've got my circle. Oh, and here's my U on the outside. Where in the world am I going to start this picture? In the middle. If I can start in the middle, I'd like to. Do I know how many supposed to go in the middle? 13. You do. All right, so I'll mark them off as we do them. 13. Let's just go from the bottom up and see if that'll work. The next one up from that says, 14 had learned This Little Light of Mine and Jesus Loves Me. What's it tell you to do? Okay, 14, and I'm going to subtract 13, which is going to give me 1. Where's the 1 going to go? Light of Mine and Jesus Loves Me. The top middle, right? Make sense? Okay, so I'm going to put a 1 here. I already did that one. Okay, and then it says 15 had learned This Little Light of Mine and the B-I-B-L-E. So what am I going to do with 15? Subtract 13, which will give me the number 2. And where will the 2 go? To the right of the 13. Down here? All right, looks good. Thanks, Madison. All right. Oh, I did this one. Let me mark it off. And then it says 13 had learned both Jesus Loves Me and the B-I-B-L-E. Now what? I need a 0. Where? To the middle left over here, right? There's a 0 there. So can we have a 0 in the diagram? Yes. Can you have a negative 2? No. There's a number of people it applies to, right? No negative people today. All right. Well, that's right. All positive people. Good. All right. Let's see. Working our way up. We've got now the 28 had learned the B-I-B-L-E. What are we going to do with that information? 28 minus 15. Because I've got 13 here and I've got 2 there. So what's that going to give me? 13. I have 13 people out here then? All right, good. 18 had learned This Little Light of Mine. Okay, so and where'd you get the 16, Mackenzie? All right, so this 1, this 13, and this 2 make a total of 16. The whole circle is supposed to be 18, which leaves me with 2 on the outside. Excellent. All right, top one, 15 had learned Jesus Loves Me. We need one more, because right now I've got 1 and 13, which is 14, so one more goes on the outside. Am I done? No.
No, the universal.
I need the number that's on the outside for the universal. Brendan says it's 2. We're heading for it. Did you get the 2? Okay. So back up here at the original part of the problem, it said that I had 34 kids in the youth group. And if I add up all these pieces, which must be what you did, right? Of course. If you add up all the pieces and you took them away from 34, did you have 2 left then? All right, so we're going to have 2 on the outside, so I'm going to take your word for it. Based on my picture, then I'm going to go up and I'm going to answer the questions. It says, how many children had learned exactly 1 song? What is that telling me to do with my picture? Okay, so exactly 1 is going to be these pieces that are not overlapping anything, right? So that's the 1 and the Jesus loves me outer part, the 2 and then this little light of mine outer part, and the 13 and the BIBLE part, which gives me a total of what? 16. How many had learned, oh, I didn't write that in quite the right spot. That goes right here. How many had learned at least 2? What does at least 2 mean? 2 or more, which means in this case they would have learned 2 or 3. All right, so where is that in my picture? This sort of can actually have 4 pieces of overlap, right? So the overlapping spots here, I've got the 1 right here, the 0, the 13, and the 2. So 1, 0, 13, and 2 gives me a total of 16. Happens to be the same number as before. How many have learned none of these songs? 2. It can happen. I knew someone in grad school who never knew any of those songs. She wasn't raised in the U.S. That's part of the reason why. All right, part D. This little light of mine, but no others.
2.
That's 2. That's just the outer part of this little light of mine circle, right? All right, I think we have time for our last slide, and we'll do group work next time. We'll also be reviewing for the test next time, right? Because when do you have the test? Monday. Monday! Right? Excited. You're all happy and excited for it? We'll talk about next time. All right. We have 2 examples on this slide. This one says, is the operation of the Cartesian product, are you guys with me? Okay, thanks. Is the operation of the Cartesian product commutative? Why or why not? So do you guys remember Cartesian product? We did that last time. We got some blank stares when I referenced it when we were doing our notes. So Cartesian product was up here, I think. Maybe it was in the last lesson. Yeah, it was in your last lesson. Okay, so I don't have the slide pulled up. Was it? What slide is it on?
Right before number 5.
Oh, there we go. It is in 5. All right, so the Cartesian product is the process of taking all of the elements from one set and pairing them with the elements in the other set, right? So the issue is, if I did the pairing with the first set first and the second set first, second, right? And then I switched them, that's commutative, right? The ability to actually switch the order. Would I end up with the same ordered pairs? So here's A cross B. Let's try it on this slide. If I did B cross A, what would I get? Oh, I'd get 1 and then X, because I'd take the number 1 from set B and group it with the X in set A. What else? How about 1Y? Can we do 1Y? 1 and Y? What else? 2X, 2Y, and 3X. Whoops, sorry about that. And 3Y. It's a pretty funky looking X there. Use your imaginations, folks. All right, so, and I'm going downhill even, look at that. All right, so are these the same ordered pairs as the first one? Are they? No. They're all switched. Okay, so think with me for a moment. If you were working on a graph, would it make a difference? If you graphed 3, 2, or 2, 3, would it matter? Yeah. Would they be the same? No. Could they be the same? If the numbers matched, right? If I did 3, 3, then it would match its split 3, 3. But in general, it's not the same. Correct? Okay. That's what this is talking about. So is it commutative? The answer is no. Because, and we can take one example for that, right? So 1x is not the same as x1. And you can refer back to, what example is that? No, refer back to, okay, I'll put slide 5 too. To slide 5. You don't end up with the same ordered pairs. It matters if you flip them. All right. Last example. Example 7. A student argues that adding 2 sets and taking the union of 2 sets is the same thing. How do you respond? You're awfully quiet in your response to the student. So it's not the same. Right? That's a good thing to say first. All right? Not the same. Let's talk about this idea of addition. Now, we have had 3 operations, I guess 4 actually, 4 operations on sets. We did union, what else? Intersection. What did you say was? Minus, you did, okay. The difference of sets was also called relative complement, has subtraction sign. And the last one is one we referenced in the example that was Cartesian product. We only talked about 4 different operations. Addition, not an operation of sets. So that's the first issue. So addition is not an operation of sets. Let's even say an operation on sets or between sets. We'll use between. However, they might be thinking about this. All right, so let me show you something that involves addition. And we saw this on a previous slide. I don't remember if it was in this lesson or not. But if we were talking about the number of items in the union, we had a formula that said the number of the items in the union, I think it was in this lesson, is the number of items in A plus the number of items in B minus the number of items in the intersection. Do you remember seeing that picture? We talked about how if we shaded a diagram, it overlapped in the middle, which means we have to subtract out the overlap. Okay. So if A and B are disjoint, that means they don't overlap.
Their circles don't overlap?
Yes, if you're drawing it as a picture, their circles will not overlap. You could also say that the items in the sets themselves don't overlap. But if they don't overlap, then what would the intersection be equal to? Right. But no, you guys are talking about union already. Pause for a second. What would the intersection be equal to if the circles don't overlap? 0, right? This is the description of the teenagers that live at my house, right? There's 0. There are no teenagers in my house. So this is 0 right here. If they do not overlap, then their intersection is 0. And if their intersection is 0, this is what Brendan was getting at, and a couple other of you said this, then the union would become what? A plus B, at least the number of items in A plus the number of items in B. So there is an addition perspective to this, but you're not actually adding sets. What are you adding here? The number of elements in the sets, and that's different, right? So there is an addition sort of perspective, but it's not addition of sets, it's addition of the number of items or the cardinality of sets. All right.